All right, so this is the first set of notes, and while in some ways this is a review of things you learned going back to Math 10, there'll definitely be some new-ish elements to it. But the focus of this is understanding function notation, which we will use a lot in this course. So I start off with a function given to you as an equation. And first, let's focus on this equation. The way we read this is we say f of x equals negative x squared plus 5. And this side of the equation is just really making it explicit about what's the input and what's the output. The x, whatever's inside the brackets here, it doesn't have to be an x, but that's the most standard way of doing it. That is the input. That is the independent variable. This function is saying if you put x in, you get out, and what you get out is f. Now I put f for function, just being boring, but again, it doesn't have to be an f. So the f there, that represents the output. The x represents the input. So what's happening? You put an x in, and f comes out, but what is the function doing? Well, that's what we see over here. This over here actually tells me as an equation what this function is doing. And negative x squared plus 5 effectively means whatever number you put into the function, you will first square it, then make it negative or multiply it by negative 1, and then add 5. That's what the equation tells you. All right, and so if I have this statement over here, f at 2, this literally means if I replace x with 2, if I put 2 into the function, what number do I get out? Well, let's just look at the equation here. Instead of having negative x squared, it's negative 2 squared plus 5. Now, keep in mind, the 2 is being squared, not the negative. And so, order of operations, do your exponents first. And so we have here negative 4 plus 5, which is 1. So you put in a 2, you get out a 1. The input is 2, the output is 1. And functions are all about inputs and outputs. If something is a function, for every one input, there's only one output. There's never multiple outputs when you put a single number in. That's it. Same idea for this next one. F at root 3. So replace x with root 3. And so I have negative root 3 all squared plus 5. Again, order of operations, first I need to go root 3 times itself. Root 3 times root 3 is root 9. The square root of 9 is exactly 3. So I might as well just go straight to this. So I have negative 3 plus 5, which is 2. And so you put in a root 3, you put in an irrational number, you get out 2, a very simple number. All right, so again, in function notation, for example, these two questions here make no sense on their own without referencing back to this. Okay, I can't ask you what f at 2 is if I don't tell you what function f does in some way. You don't have to express a function as an equation, but that's what we're starting with. Okay, so a little more going on here. Again, these two expressions down here make no sense. You can't really do much unless you keep referring back to what f of x is, which I've given you at the top. And so 2f at 1 literally means put 1 into function f, figure out what that is, and then multiply all that by 2. It's 2f at 1. And so for this, first let me think what f at 1 would be. And that would be negative 1 squared plus 5, and all that's times 2. And so first let's figure out what negative 1 squared plus 5 is. And again, the negative is not being squared, just a 1 is. So it's negative 1 plus 5, all times 2, which is 2 times 4, which is 8. So what this tells me is when I put in a 1 to the function, I get out a 4. Actually, I should highlight this part, right? That part there. That's what happens when I put a 1 into function f, but then I'm still multiplying it all by 2, so in the end I get out 8. 2 times f at 1 is 8. Well, it's just f at 1 is 4. So a bit more going on here, same idea. And so first, let me focus on what just f at 3 is, because this really means 2 times f at 3 take away 6. So first I need to figure out what is f at 3. And same idea. So I have negative 3 squared plus 5. And all of that is being multiplied by 2 and having 6 subtracted from it, but one step at a time. Let's first focus on what is just f at 3, just this part. So negative 3 squared plus 5 is negative 9 plus 5, which is 4. But all that's times 2, and then take away 6. Order of operations, 2 times 4 is 8. 8 take away 6 is, I made a mistake here. Sorry, that should be a negative in front of the 4. And so this should be -8, and -8 take away 6 is -14. So again, I put 3 into f, I get out -4, but then if you look back at the expression I gave you, I take all of that, multiply by 2, and subtract by 6. All right, so keep in mind, a function doesn't have to be expressed as an equation. It can be expressed in many ways. And these courses, the two most common ways of expressing a function is an equation, which I've shown you, or as a graph. And that's what I want to look at here. So this is a different function. This is g of x. And so I'll just kind of label on the graph. And this time, instead of telling you what g of x is as an equation, I've shown you what it is as a graph, the graph of the function. Now, you could probably assume this is going to keep going on down here. Sure looks like a quadratic function. It is a quadratic function. And so if you look at this, my first few questions are the same as before. I start with what is g at 4, which means I put 4 into the function g, not f anymore. What do I get out? So if you're tempted to find the equation of this parabola, that's great. I'm not going to do it though, because I don't have to, at least not yet. And so I don't actually need to find, at least for some time, the equation of this function. Okay, if I do find the equation of this quadratic function, which you've learned about in pre-calculus 11, it's not a bad idea at all. We just don't have to, and it will be more work. And so if I have to do it, I'll do it. But right now, how can I figure out what g at 4 is without actually finding the equation? Well, don't forget, that 4 that I've highlighted is the input. That's my x. And, you know, this means if x is 4, what is y? What is the output? Well, I can just look at my graph and see, okay, where is x 4? That's right here. So at this point right here, that point I'm drawing, that's where my function g has an x coordinate of 4. So what's the output? What's the y coordinate? I can see that's at 3. So there we go. I'm done. When x is 4, y is 3. When x is 4, g is 3. Or when the input is 4, the output is 3. We always want to keep in mind inputs and outputs, right? And the most common way to think about that is x being the input, y being the output. And if I did find the equation for g of x, if I did it correctly, I should get the same answer, but it's hard to say that's what I just did here isn't pretty fast. And so similarly here, I have negative g at 3. So let's first figure out what just g at 3 is. So let's look at where x equals 3. My input is 3, which is right here. And so my output is at 4. So just g at 3 equals 4. But it's not g at 3, it's negative g at 3. So there's a negative in the front. And now I'm done. Negative 4. All right. And then so for next, 5 times g at 2 times, sorry, take away 1. Well, again, let's first figure out what just g at 2 is. And again, why not just use the graph? When x is 2, the output is again 3. So just g at 2 is 3. However, I still have to multiply that by 5 and then subtract 1. Well, that's pretty easy. 15 take away 1 is 14. All right, so again, if you did find the equation for this parabola here, you should get the same answers for these 3 questions, but it's definitely more work. Definitely more work. However, for the last 2, I'm not looking for a number. I'm looking for an expression for my answers. Here, I need to find the equation. So to do anything more here, because x is just x, I don't know what x is. You know, the graph at this point, I need to use it to find the equation. So let's put this on hold. Let's look over here. Let's remember our grade 11 math. I'll just kind of erase this. One thing I can see is that this is a parabola with a vertex at 3, 4, which means I know the equation for g of x must have this sort of form where it's going to be, go away, it's going to be x minus 3 all squared plus 4. And that's remembering how a quadratic function, if you know where the vertex is, you know where at least how most of your equation looks. I can also tell that my parabola is opening down. And if I look at the equation I wrote right here, that would actually open up because there's no number there, which means it's positive 1. So I know whatever goes in the front here must be at least negative. But how do I know it's not negative 2 or negative 1.7? Well, now I look at the details of my graph and I see that if I look at these other points, it perfectly follows, it's congruent to the graph of x squared. Graph of x squared from the vertex, your next point is 1 over and 1 down if it's reflected down, 2 over and 4 down. That's exactly what I'm seeing. So I know compared to the graph of x squared, it's been reflected vertically, but it has not been stretched, which means I now know by quickly reviewing some key parts of Pre-Calculus 11, I now know that that is the equation. Now, I will say the very next lesson is reviewing these sort of details from quadratics. So if what I did there was pretty fast, fair enough. If hopefully it sounds familiar. All right, so now that I know the equation of g of x, so let me just kind of write that down here a bit more again. Right, now that I know that g of x is negative x minus 3 squared plus 4. Now I could redo the previous questions, but why do that? I'm now going to focus on this. So notice right here, I'm asking for not g of x, I'm asking for essentially what's the equation of minus g of x, which means everything I wrote right here, but the entire thing is negative. So what does that look like? Got to be a little bit careful. So let me just write down first, negative x minus 3 squared plus 4, but the whole thing is negative. Right, and I'll use my highlighter again. That's g of x, that's g of x. The whole thing is negative. And so notice I have to, if I want to get rid of these brackets, which I probably should, what I have here is correct, it's just needlessly messy. What I probably really should do is distribute that negative, same as multiply by negative 1. And so what I end up with is positive x minus 3 squared take away 4. And that is the equation for minus g of x. The equation for g of x was, we figured out already, this is the equation of minus g of x. And so finally, what is the equation of g at 2x? Well, again, I want to come back to this equation right here. But instead of the input being x, the input is 2x. Now, what do I do with that? Well, I'm literally going to go back to my equation and replace that x I've highlighted with 2x and leave everything else the same. Now again, if that seems kind of strange, just keep in mind it's the exact same thing we did in these questions up here. If I go back here, I don't know, f at 2, instead of an x right here, there's a 2. So I replace the x with 2. Well, in this case, instead of a x, there's a 2x. So I replace the x with 2x. Now at this point, there's really nothing more I need to do. The equation I have here is, there's nothing wrong with it. There's no need, I can't easily cancel out something or simplify it clearly. So I'll just leave it like that. If you are tempted to, take this part here and expand and simplify it, like basically FOIL that out, just keep in mind that means 2x minus 3 times 2x minus 3, right? And while there's some shortcuts, it takes a few steps. Really, in the end, what you end up with is not inherently any better than what I have right here. So I'll just stick with that. And so with that said, like I said, this is technically kind of a review lesson, but the type of questions I asked, especially where I was combining, something in function notation with some other operations around it, you probably haven't done that before, or definitely not much. I wouldn't be surprised. So for your homework, the homework today is not from a textbook or anything like that. The homework, I have a Socrative activity, and it should be running right now. Well, that, at least if you're looking at this video when you should be looking at it. And so I'll have details, again, remind you how to access that Socrative activity on the Teams page. All right, so that's all. Thank you.